Oh, I am live. Good afternoon. So, in this series, we will be learning the C programming language. And for that, I am not an expert, so we will be going through this book. I will be learning the C programming language through this book, and maybe that might help you. And that is the reason that you might want to watch this series, right? So, yep, that is the whole point. I will be going through this book and doing the exercises and everything in this book. And if you want to watch me reading a book and learning something, then good. Otherwise, I can just send this series to my recruiter and he can see I actually know stuff. Yep, here is the interface, and the target is that I would like to complete this series in 30 videos at max. That is in a month. And I would be streaming at least 2 hours every day. So that is 2 hours every day for a month. How much time? 60 hours for C language. That is good, I guess. Now, preface. What the heck is preface? The computing world has undergone a revolution since the publication of the C programming language in 1978. Big computers are much bigger, and personal computers have capabilities that rival mainframes of a decade ago. During this time, C has changed too, although only modestly, and it has spread far beyond its origins as the language of the Unix operating system. Unix operating system, that is cool. The growing popularity of C, the changes in the language over the years, and the creation of compilers by groups not involved in its design combined to demonstrate a need for a more precise and more contemporary definition of the language than the first edition of this book provided. In 1983, the American National Standard Institute (NC) established a committee whose goal was to produce an unambiguous and machine-independent definition of the language C while still retaining its spirit. The result is the ANSI standard of C. That makes sense. The standard formalizes constructions that were hinted but not described in the first edition, particularly structure assignment and enumerations. It provides a new form of function declaration that permits cross-checking of definition with use. It specifies a standard library with an extensive set of functions for performing input and output, memory management, string manipulation, and similar tasks. It makes precise the behavior of features that were not spelled out in the original definition, and at the same time states explicitly which aspects of the language remain machine dependent. That makes sense. So in the start, there was when the C programming language was first developed, there was a book called the C programming language, which was written by Dennis Ritchie and Brian Kernighan. But then over the years, the C language spread and there was a need for a more standard definition. Then came the ANSI C language, this ANSI standard for the C language, and this book describes that ANSI standard. The second edition of the C programming language describes C as defined by the ANSI, not ANSI, ANSI standard. Although we have noted the places where the language has evolved, we have chosen to write exclusively in the new form. For the most part, this makes no significant difference. The most visible change is the new form of function declaration and definition. Modern compilers already support most features of the standard. Okay, we have tried to retain the brevity of the first edition. C is not a big language and it is not well served by a big book. We have improved the exposition of critical features such as pointers that are central to C programming. We have redefined the original examples and have added new examples in several chapters. For instance, the treatment of complicated declarations is augmented by programs that convert declarations into words and vice versa declaration, like with hashtag. As before, all examples have been tested directly from the text, which is in machine reliable form. Appendix A. The reference manual is not the standard but our attempt to convey the essentials of the standard in a smaller space. It is meant for easy comprehension by the programmers, but not as a definition for compiler writers. That role properly belongs to the standard itself. Appendix B is a summary of the facilities of the standard library. It too is meant for the reference by programmers, not implementers. Appendix C is a concise summary of the chapter changes from the original version. Okay, as we said in the preface of the first edition, C wears well as one's experience with it grows. With a decade more experience, we still feel that way. We hope that this book will help you learn C and use it well. We are deeply indebted to friends, and these are thank yous. We used Yarn Strop's C++ translator extensively for local testing of our programs, and Dave Crystal provided us with an ANSI compiler for the final testing. Rich Drester helped greatly with type testing. Our sincere thanks to all. Brian Kernighan and Dennis Ritchie. KNR. Preface to first edition. Okay. Preface to the first edition. C is the general purpose programming language with features economy of expression, modern flow control and data structures, and a rich set of operators. C is not a very high level language or a big one and is not specialized in any particular area of application, but its absence of restrictions and its generality makes it more convenient and effective for many tasks that is supposedly more powerful language. Supposedly more powerful languages. Okay. C was originally designed for and implemented on the Unix operating system on the DEC PDP-11. DEC PDP-11 is the most famous computer that was ever built somehow by Dennis Ritchie. And Dennis Ritchie made created the C programming language, the operating system, the C compiler, and essentially all Unix application programs, including all of the software used to prepare this book, are written in C. Production compilers also exist for several other machines, including the IBM System 730 in Honeywell 6000 and Enterdata 832. C is not tied to any particular hardware or system. However, it is easy to write programs that will run without change on any machine that supports C. This book is meant to help the reader learn how to program in C. It contains a tutorial introduction to get new users started as soon as possible, separate chapters on each major feature, and a reference manual. Most of the treatment is based on reading, writing, and revising examples rather than on mere statements of rules. For the most part, the examples are complete real programs rather than isolated fragments. All examples have been tested directly from the text, which is in machine readable form. Besides showing how to make effective use of the language, we have also tried, where possible, to illustrate useful algorithms and principles of good style and sound design. The book is not an introductory programming manual. It assumes some familiarity with basic programming concepts like variable assignment, statements, loops, and functions. Nonetheless, a novice programmer should be able to read along and pick up the language, although access to more knowledgeable colleagues will help. In our experience, C has proven to be a pleasant, expensive, and versatile language for a wide variety of programs. It is easy to learn and it wears well as one's experience grows with it. It wears well as one's experience grows with it. We hope that this book will help you use it well. A thankful criticism and suggestion, and thank you to everyone. Brian Kernighan, Dennis Ritchie. Chapter 1, a tutorial introduction. Let us begin with a quick introduction. In C, our aim is to show the essential elements of the language in real programs, but without getting bogged down in details, rules, and exceptions. At this point, we are not trying to complete or even precise. Save the examples are meant to be correct. We want to get you as quickly as possible to the point where you can write useful programs, and to do that, we have to concentrate on the basics, variables and constants, arithmetic, control flow functions, and the rudiments of input and output. We are intentionally leaving out of this chapter features of C that are important for writing bigger programs. These include pointers, structures, most of C's rich set of operators, several control statements, and the standard library. This approach and its drawbacks. Most notable is that the complete story on any particular feature is not found here, and the tutorial, by being brief, may also be misleading. And because the examples do not use the full power of C, they are not as concise and elegant as they might be. We have tried to minimize these effects, but be warned. Another drawback is that later chapters will necessarily repeat some of this chapter. We hope that repetition will help you more than it annoys. That makes sense. In any case, concerned programmers should be able to extrapolate from the material in this chapter to their own programming needs. Beginners should supply it by writing small similar programs of their own. Both groups can use it as a framework on which to hang the more detailed descriptions that begin in chapter 2. That makes sense. Getting started. Now, I have to get started here as Dennis Ritchie and Brian Kernighan tells me to. The only way to learn a new programming language is by writing programs in it. The first program to write is the same for all languages. Print the words "Hello World." This is a big hurdle. To leap over it, you have to be able to create the program text somewhere, compile it successfully, load it, run it, and find out where your output went. With these mechanical details mastered, everything else is comparatively easy. So we have to write this, create the program text somewhere. Yep, we have to write that program somewhere. Then we have to compile it successfully. Then we have to load it and run it. That makes sense. And then we will have to see where the output of that program went. In the C programming language, to print hello world, it is just these main print hello world with the new line. Just how to run this program depends on the system you are using. As a specific example, on the Unix operating system, you must create the program in a file whose name ends in .c, such as hello.c, then compute it with the command this cc c compiler hello.c, that is, compile this file. If you haven't botched anything, such as omitting a character or misspelled something, the compiler will proceed silently and make an executable file called a.out. If you run a.out by typing the command a.out, it will print hello world. On another system, the rule will be different. Check with a local expert. Well, we can write this program right now. Not a big deal. Um, ah, um, and then in this n, so I am right now in the folder where I will be writing programs for this book, and here I am writing chap hello world dot c. Here we have include io dot h and then main printf hello world new line, and then compile it with the Clang compiler to an output file named .out, and then I will run the output file and hello world. On other systems, yep, check with the local expert. Now for some explanations about the program itself. A C program, whatever its size, consists of functions and variables. A function contains statements that specify the computing operations to be done, and variables store value. A function contains statements that specify the computing operations to be done, and variables store values used during the computation. The C functions are like the subroutines and functions in Fortran, or the procedures and functions of Pascal. Our example is a function named main. Normally, you are at liberty to give functions whatever name you like, but main is special. Your program begins executing at the beginning of the main. This means that every program must have a main somewhere. Main will usually call other functions to help perform its job, some that you wrote and other library and others from libraries that are provided for you. The first line, this tells the compiler to include information about the standard input-output library. The line appears at the beginning of many C source files. The standard library is described in chapter 7. Okay, this file includes the standard library, it is standard input-output library. And about functions, we can do this. How do I define a function? Yep, this does not take anything. What it does is it prints hello world, and here I am going to call the first, here I will write the prototype for the function, and in the main function I will call that. That is just very stupid, but let's just do it. And hello world. One method of communicating data between functions is for the calling function to provide a list of values called arguments to the function it calls. The parentheses after the function name surround the argument list. In this example, main is defined to be a function that expects no arguments, which is indicated by the empty list. Makes sense. This tells the compiler to include the standard library for input and output. Include information about standard library. Library is written here somehow. Main. Define a function called main that receives no argument values. Here are the statements. Statements of the main are enclosed in braces. Main calls library function printf to print the sequence of characters. Backslash n represents the new line character. Line. The statements of a function are enclosed in braces. The function main contains only one statement. This one. Printf hello world \main. A function is called by naming it. A function is called by naming it, followed by a parenthesized list of arguments. So this calls the function printf with the argument hello world. Printf is a library function that prints output, in this case, the string of characters between the quotes. A sequence of characters in double quotes like hello world \n is called a character string or a string constant. For the moment, our only use of character strings will be as arguments for printf functions and other functions. Okay, these are called string character strings. That is strings of characters. Single characters stored one after the other, and at the end they have a null termination, that is zero. A whole byte, that is just zero, signifies the end of the string. The sequence \n in the string is C notation for the new line character, which, when printed, advances the output to the left margin of the next line. If you leave out the \n, a worthwhile experiment, you will find that there is no line advance after the output is printed. You must use \n to include a new line character in the printf argument. If you try something like this, printf, the C compiler will produce an error message. Printf never supplies a new line character automatically, so several calls may be used to build up and output a line in stages. Our first program could just as well have been written like this: print hello world and then backslash n to produce identical output. This will be identical output, not the program. Program will not be identical. I'm calling the same thing three times here to produce the identical output. Notice that backslash n represents only a single character. An escape sequence like backslash n provides a general and extensible mechanism for representing hard to type or invisible characters. Among others that C provides are backslash T for tab, backslash B for backspace, backslash quotes for double quotes, and backslash for backslash itself. There is a complete list in section 2.3. Exercise 1, that is run the Hello World program on your system. Experiment with leaving out parts of the program to see what error messages you get. We have written the program. Exercise 1.2, experiment to find out what happens when printf's argument strings contain backslash c, where c is some character not listed above. Backslash. Okay. Backslash c. Well, hello, hello, backslash n, unknown escape sequence. Okay, if I compile, I will get some error. That is an unknown escape sequence. Hello world. Variables and arithmetic expressions. The next program uses the formula this to print the following table of Fahrenheit temperatures and their Celsius, centigrade or Celsius equivalents. This is the formula, folks. Like, here is the formula: equals MC square. The program itself still consists of the definition of a single function called named main. It is longer than the one that printed. Okay, we will print our own. We will make our own function which implements this formula. We'll do an Celsius.c. Aha. This is the formula. Okay. Include standard IO main and int I equal starting from 1 1. Okay, multiply by 20 from 1 till 300. A weird choice. Okay, for I and I equal to 1. Well, maybe so first one has to be 1 and then 20, so I cannot add 20, right? So I think I can calculate the Celsius for this manually and then put the rest of them in a loop. Or I can also write a function here that would return me an integer, and the function's name is cf2c. It will take an integer I or temp F, and it has to now find Celsius for it. So int C equal temp C equals 5 divided by 9, and then I have to multiply it. Yep, multiply that by temp F minus 32. Oh, what function does not return a value? Wow, whoa, expected non-void function. Oh, okay. Then return temp C. Semicolon. Of course, prime suspect. And here I will give a function prototype f2c takes in an integer, and here I will get the first int f equals temp equals f2c for 1, and then you can call I can make a function which will take in two integers, int temp c and int temp f, and printf %d for %d, and then new line, and the numbers would be temp c and temp f, and print with first will come temp and then 1, and here the prototype void print int takes into integers, and then I will print the function. I will go through a loop. Temp equals 20 for nothing, temp less than equal to 300, temp while loop, while temp is less than equal to 300. What do I want to do? Print print f2 c for temp and temp, and then temp plus equal increase temp by 20. That should do it. Not hello world, but Celsius, and the output should be out. God damn it. Okay. Why is it 0? First integer. Why is it 0, 0, 0? I would like these to be in float and this 2 to be in float and this 2 to be in float, and then and this 2 to be in float, and everything to be in float. Yeah, float rocks. It will take in float. Oh, oh, FT. What is the thing for FT? Ah, I guess it is FT here. It works now, and this one will also take in float, and this one will also take in float and then return float. This should work, I guess. It does work, but in the opposite, why and why is there a T at the end? Oh, because F is sufficient, and I need to tell it that I want only two decimal places. Dot two. I think that is the format. Yep, but it is printing them the wrong way. The first one has to be F and the second one has to be C. Like your mom. Yeah. Clang and now what the heck? Shetrol. Cert tool. Oh, I forgot about it. Cert bot. Yep. And now it works. Wait, I do not want this one to be float. This is just good as an integer. Oh, this one has to be float, but this one is good as an integer. Yep, that should be good. Yeah. Okay, it is only taking 4 spaces and the spaces are messed up. Okay, the number of spaces has to be fixed. The number of spaces. I have to fix the number of spaces. Hmm. 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 I can do that. I can actually do that. I will see. The number of spaces will depend on Fahrenheit temperature. So I need to figure out how many digits are there in the Fahrenheit. And how can I do that? I can do that by seeing okay, I can do that actually. Int space equal tempf divided by 10. What will this give me? I don't want to divide it by 10. It has to be exactly equal to 10. And now instead of doing all of this, after this I can do while space greater than 0, do this printf space, just a single space, and space equal to space divided by 10. This will remove one uh, double quotes. Yep, this will remove one. This line will keep removing one digit from space, and this one will keep printing one space. Wait, what the heck is this? It will print spaces as many characters there are. Yes, I do not want that. I want to have a fixed amount of spaces. Let's say 8 spaces. So if there are 3 characters, then I want to start printing the Celsius number after after providing 5 spaces. So I have to okay, instead of printing spaces, I can do this int space equal this, and I guess this is very stupid. Int and int space equal to 0, and I will do this till num is greater than equal to 0, and nope, not space, but I have to reduce one digit from num, and space just keeps, nah, it should not be space, it should be digit. Digits, digits plus plus 1, and spaces will be equal to 8 minus digits. Now while space is greater than 0, I do printf space, and after that I'll just printf %f with temp c, and also a new line. Not node, but this. That is amazing. Just what I expected. Shit. No. Wait, so what the heck is happening? Num is divided by 10. Then while space is greater. Okay. Space is minus minus. Plus and this. Spaces are good now. Oh, yep. Yes. The number of decimal digits has to be fixed. 2 digits should be good. And dot out. Let's function it. Now we have written this program. We don't actually need decimal numbers. Well, we don't actually need float numbers. Do we? Well, not in the end, at least. Instead of doing, I can just do digit. Temp c can also be an integer, and here also it can be an integer. Now we have the exact same output. And how is the stream going? 40 minutes into the stream, and yep, I seem to be live. Part 1, learning C programming language. Gargantua here. The program itself still consists of the definition of a single function named main. It is longer than the one that printed hello world, but not complicated. It introduces several new ideas, including comments, declarations, variables, arithmetic expressions, loops, and formatted outputs. Include standard io.h, then print. Okay, that is just a comment. In the main function, we have Fahrenheit and Celsius, and then we have int lower, upper, and step. That is much better than what I did, I guess. Lower is 0. Oh, shit, you had to start with 1, didn't you? Lower is 1. Upper is 300. Step is 20. Lower limit of temperature. Yeah. And then Fahrenheit equals lower, while Fahrenheit less than equal to upper. What do I do? Celsius equals. I calculate the temperature, then I print with a tab. And this the tab, and shit, I could have done tab. Ah, shit. Shit. Here I could have done tab %d and new line, and here temperature of Celsius lang and /shout, and it still works. Well, I wrote the implementation for tab. That is good. The two lines, these are a comment, which in this case explain briefly what the program does. Any character between this and this are ignored by the compiler. They may be used freely to make program easier to understand. Comments may appear anywhere where a blank tab or new line can. In C, all variables must be declared before they are used, usually at the beginning of the function before any executable statement. A declaration announces the properties of a variable. It consists of a name and a list of variables such as integer add variables. The type int means that the variable lists are integers, by contrast with float, which means float point, that is, numbers that may have a fractional part. The range of both int and float depends on the machine you are using. 16-bit ints, which lie between minus 32,000 and plus 32,000, are common, as are 32 bits, 32-bit ints, which are about 4 billion, ranging from minus 2 billion to plus 2 billion. A float number is typically a 32-bit quantity with at least 6 significant digits and magnitude, generally between minus 10 power minus 30 to plus 38. C provides several other data types include besides int and float, including character, a single byte. That is literally what I said, a single byte. Short, short integer, long integer, double precision floating point, that is 64 bits. The size of these objects is also machine dependent. There are also arrays, structures, and unions of these basic types, pointers to them, and functions that return them, all of which we will meet in due course. Computation in the temperature conversion program begins with the assignment statements. We assign values 0, 300, and 20 to these variables, which set the variables to their initial values. Individual statements are terminated by semicolons. Yep. Each line of the table is computed the same way, so we use a loop that represents once per output line. This is the purpose of the while loop. Each line of the table is computed the same way, so we use a loop that repeats once per output line. This is the purpose of the while loop. That makes sense. The while loop operates as follows. The condition in parentheses is tested. If it is true, far far is less than or equal to upper Fahrenheit, the body of the loop, the three statements enclosed in braces, is executed. Then the condition is retested, and if true, the body is executed again. When the test becomes false, far exceeds upper, the loop ends and execution continues, and the statement that follows the loop. There are no further statements in this program, so it terminates. The body of a while loop can be one or more statements enclosed in braces, as in temperature converter, or a single statement without braces, as in this while and single statement without braces. In either case, we will always indent the statements controlled by the while by one tab stop, which we have shown as four spaces. So you can see at a glance which statements are inside the loop. The indentation emphasizes the logical structure of the program. Although C compilers do not care about how a program looks, proper indentation and spacing are critical in making programs easy for people to read. We recommend writing only one statement per line and using blanks around operators to specify a grouping. The position of braces is less important. The position of braces is less important, although people hold passionate beliefs. We have chosen one for several popular styles. Pick a style that suits you, then use it consistently. Most of the work gets done in the body of the loop. The Celsius temperature is computed and assigned to the variable Celsius by the statement this. Multiply by 5 minus 32 from Fahrenheit, multiply it by 5 and divide it by 9. The reason for multiplying by 5 and dividing by 9 instead of just multiplying by 5 by 9 is that makes sense. In C, as many other languages, integer division truncates. Any fractional part is discarded in integer division. Since 5 and 9 are integers, 5 by 9 would truncate to 0, and so all this Celsius temperature will be reported as 0. That makes sense, and that is the problem that I was facing earlier while writing the program on my own. This example also shows a bit more of how printf works. Printf is a general purpose output formatting function which we will describe in detail in chapter 7. It is its first argument. Chapter 7 consists of explanation for the standard library, and printf is a function of the standard library. Its first argument is a string of characters to be printed which with each percent indicating where one of the other second, third arguments is to be substituted and in what form it is to be printed. For instance, person D specifies an integer argument. So the statement printf this prints a digit here, then a tab, then a digit here, and then a new line. Causes the values of the two integers Fahrenheit and Celsius to be printed with a tab between them. And the tab has specific boundaries of 8 or 4 characters. For example, if you are at the start of a line and you have written 5 characters and then you press tab, then you will get 3 spaces. But if you have written only one character, then you will get 7 spaces to get at the 8 spaces boundary. By the way, printf is not part of the C language. It is no, there is no input or output defined in C itself. There is no input or output defined in C itself. Printf is just a useful function from the standard library of functions that are normally accessible to C programs. The behavior of printf is defined in the ANSI standard, however, so its properties should be the same with any compiler and library that conforms to the standard. Okay, so the compiler has with itself a standard library from which we can call functions which adhere to the ANSI standard. In order to concentrate on C itself, we don't talk much about input and output until chapter 7. In particular, we will defer formatted input until then. If you have to input numbers, read the discussion of the scanf function. In section 7.4, scanf is like printf except that it reads input from of writing output. There are a couple of problems with the temperature conversion programs. The simpler one is that the output isn't very pretty because the numbers are not right justified. That's easy to fix if each argument %d if we argument each %d in the printf statement with width, the numbers printed will be right justified in their fields. For instance, we can tell that this number takes 3 bytes and this number takes 8 spaces, this number takes 3 spaces. That makes sense. To print the first number of each line in a field 3 digits wide and the second in a field 6 digit wide, like this. That makes sense. The more serious problem is that because we have used integer arithmetic, the Celsius temperature are not very accurate. For instance, 0 Fahrenheit is actually about 17.8 and not 17. To get more accurate answers, we should use floating point arithmetic instead of integers. This requires some changes in the program. Here is the second version. Okay, instead of doing this, I can do int Celsius, Fahrenheit, and integer start and step, and while Fahrenheit less than equal to end, I do F2C for Celsius and am I stupid? 0 Fahrenheit is the one that I'm converting. Yeah, so I have to give it Fahrenheit. Fahrenheit, and that makes sense. Takes in a float, returns a float, and both of them are float, and this also works with float, and output we get is float. But here what we print is also float. Replace with float. Find the replace with float. And this also with float and dot slash out. Oh, Celsius. While Fahrenheit less than equal to end. I did not initialize Fahrenheit. Okay. So step equals 20 and Fahrenheit equals 0.0 and end equals 300. Celsius, and I would only like to have dot 2 decimal places with total number of 3 digits in this, and with a total number of 6 digits in this, with two of them decimal places. That works. For the first one, I do not actually need any decimal places, so I can write it as with 0 decimal places. In Celsius, but I would like it to be right aligned, for which I can do this. And now it is right aligned. As you like it, Shakespeare. Requires some changes in the program. Here is the second version. This, okay, these are float now. Everything is float now. Lower upper step. And while Fahrenheit less than equal to this, and Celsius 5.9 divided by 9.0, Fahrenheit divided by this, and print three spaces with zero decimal spaces and one decimal space for that. Okay. This is much the same as before, except that Fahrenheit and Celsius are declared to be float, and the formula for conversion is written in a more natural way. We were unable to use 5 by 9 in the previous version because integer division would truncate it to 0. A decimal point in a constant indicates it is floating point, however. So 5.9 and 9.60 is not truncated because it is the ratio of two floating point numbers. That makes sense. So it will be stored in with decimal points after the zero, decimal numbers after the zero. If an arithmetic operator has integer operands, an integer operation is performed. If an arithmetic operator has one floating point operand and one integer operand, however, the integer will be converted to floating point before the operation is done. If we had written Fahrenheit minus 32, the 32 would be automatically converted to floating point. Nevertheless, writing floating point constants with explicit decimal points, even when they have integral values, emphasizes their floating point nature for human readers. The detailed rules for when integers are converted to floating point are in chapter 2. For now, notice that assignment Fahrenheit equals lower and the test Fahrenheit less than equal to upper are also in the natural way. The int is converted to float. We don't have an int. Both of them, Fahrenheit and lower, Fahrenheit and upper, are float. So we do not have a conversion here. It seems like the printf conversion is specification. Percent 3.0f says that a floating point number here Fahrenheit is to be printed at least 3 characters wide with no decimal points and no fraction digits. 6.1 describes another number, Celsius, that is to be printed at least 6 characters wide with one digit after the decimal point. The output looks like this. Yo, with width and precision may be omitted from a specification like this says that the number is to be at least 6 characters wide. 2 specifies 2 characters after the decimal, but the width is not constrained, and %f merely says to print number as floating point. %d for decimal, 6d print decimal with 6 spaces, 6 characters wide. F for print as float, 6f print a floating point number with 6 characters wide, at least 6 characters wide. Point 2 specifies that print a floating point number, 2 characters after the decimal point, and this specifies it print a floating point number which should take at least 6 characters and should take 2 decimal points. Among other printf Among others, printf also recognizes %O for octal, %X for hexadecimal, %C for character, %S for character string, and %% for itself. Modify the temperature conversion program to print a heading above the table. We got that. Write a program to print the corresponding Celsius to Fahrenheit table. We also got that. Bah. I do not want to spend too much time with the smaller things. This is very easy. This is also very easy. Now this. The for statement. There are plenty of different ways to write a program for a particular task. Let's try a variation on the temperature converter. Include stdio.h print Fahrenheit Celsius table. Uh, we initialize the Fahrenheit for Fahrenheit equals 0. Yeah, we can do the for statement and do this. Fahrenheit equals 0, Fahrenheit less than, while it is less than equal to 300. What do? We keep adding. Okay, so this is the way we, okay, so we have to provide, instead of a expression, we can provide a statement here. Okay, and then print our function here like this. Makes sense. This produces the same answers, but it certainly looks different. One major change is the elimination of most of the variables. Only Fahrenheit remains, and we have made it an int. The lower and upper limits and the step size appears only as constants in the for statement itself. New construction and the expression that computes the Celsius temperature now appears as the third argument of printf instead of a separate assignment statement. That makes sense. This last change is an instance of a general rule. In any context where it is permissible to use the value of some type, you can use a more complicated expression of that type. That makes sense, since the third argument of printf must be a floating point value to match the 6.1f. Any floating point expression can occur before here. Since the third argument of printf must be a floating point value to match this 0.61f, any floating point expression can occur there. Here. That makes sense. Instead of writing the value here, we can provide an expression which returns a floating point. The for statement is a loop, a generalization of the while. If you compare it to the earlier while, its operations should be clear. Within the parentheses, there are three parts separated by semicolon. First, assignment initialization is done once before the loop proper is entered. The second part is the test and condition that controls the loop. This is the test and condition that controls the loop. This condition is evaluated if it is true. The body of the loop, there here a single printf is executed. Then the increment step, this statement is executed and the condition is re-evaluated. The loop terminates if the condition has become false. As with the while, the body of the loop can be a single statement or a group of statements enclosed in braces. The initialization condition and increment can be any expressions. That also makes sense. The choice between while and for is arbitrary, does not matter, based on which seems clearer. The for is usually appropriate for loops in which the initialization and increment are single statements and logically related, since it is more compact than while loop and it keeps the loop control statements together in one place. Now, modify the temperature conversion program to print the tables in a reverse order, that is from 300 to 0. The increment statement would change, it would be subtracting 20, and the test statement would change, it would check for Fahrenheit greater than equal to 0. Now we have symbolic constants, which is something. It has only been 1 hour. That is literally crazy. I think we will finish this chapter today. How long is this? We are at symbolic constants, part 1.4. What is the page number? 17. And we have a few things, arrays and functions. Okay, from 17 till shit, that is a bit long. Maybe it will take us till tomorrow to complete this chapter. Page number 34. Okay, okay, tomorrow we will complete this chapter and begin with chapter number 2, types and operators, from day after tomorrow. Today we have to do as much as we can for the hour that we have left. There are plenty of different ways to write a program for a particular task. Let's try a variation on the temperature converter. Include standard IO and we have. I'm being stupid. We did that. A final observation before we leave temperature conversion forever. It's a bad practice to bury magic numbers like 320 in a program. They convey little information to someone who might have to read the program later, and they are hard to change in a systematic way. One way to deal with magic numbers is to give them meaningful names. Percent, a hash define line defines a symbolic name or symbolic constant to be a particular string of characters. Define name and a replacement list. Thereafter, any occurrence of name, not in quotes and not part of another name, will be replaced by the corresponding replacement text. The name has the same form as a variable name, a sequence of letters and digits that begin with a letter. The replacement text can be any sequence of characters, it is not limited to numbers. Okay, the quantities lower, upper, and step are symbolic constants, not variables, so they do not appear in declarations. Symbolic constant names are conventionally written in uppercase, so they can be readily distinguished from lowercase variable names. Note that there is no semicolon at the end of definition list of a hash defined line. You gotta ask ChatGPT what is the difference between variables and symbolic constants in the C language. Yes, in C, both variables and symbolic constants are used to store values, but they have a key difference. Variables, in terms of mutability, definition, and usage. A variable is a name. Oh, symbolic constants are constants. Variables. A variable is a name, a storage location in memory that holds a variable. Variable is a named storage location in memory that holds a variable. Its value can be changed during program execution. It is declared using a data type. Example, int x equal this. Symbolic constants. A symbolic constant is a fixed value that cannot be changed once defined. Defined using either hash defined preprocessor directive. Okay, so preprocessor handles this when we are using hash defined, replaces the occurrences of pi with this during pre-processing. That is okay. This does not consume memory in the RAM. Of course, does not. Does not consume no storage on RAM. Constant key. Const int max equal 100. Constant keyword stored in memory but read only type safe, unlike hash defined which has no type. It is type safe. Okay. Key difference. Value modification. Variables can be modified. Symbolic constants cannot be. Definition. Declared with a data type. Declared using hash define and const. Memory uses occupies memory. Does not occupy memory. Scope follows block function scope rules. Has a global scope. Person const is type checked. Define is not type checked. Okay, when to use. Ah, so the preprocessor handles symbolic constants. Now, character input and output. We are going to consider a family of related programs for processing character data. You will find that many programs are just expanded versions of the prototypes that we discuss here. You will find that many programs are just expanded versions of prototypes that we discuss here. Okay, the model of input and output supported by the standard library is very simple. Text input or output, regardless of where it originates or where it goes, is dealt with as a stream of characters. Text input or output, regardless of where it originates or where it goes to, is dealt with as streams of characters. A text stream is a sequence of characters divided into lines. Each line consists of zero or more characters followed by a new line character. It is the responsibility of the library to make each input or output stream confirm this model. C programmer using the library need not worry about how lines are represented outside the program. The standard library provides several functions for reading or writing one character at a time, of which getChar and putChar are the simplest. Each time it is called getChar reads the next character input from a input text stream and returns it as its value. That is after C equals getChar. C is that. The variable C contains the next character of input. The characters normally come from the keyboard input files discussed in chapter 7 is going to be a banger. The function putChar prints a character each time it is called. Putchar C prints the contents of the integer variable C as a character, usually on the screen. Calls to putchar and printf may be interleaved. The output will appear in the order in which the calls are made. The output will appear in the order in which calls are made. That makes sense. File copying a file from one place to another. Hmm. Uh, Given getchar and putchar, you can write a surprising amount of useful code without knowing anything more about input and output. The simplest example is a program that copies its input to its output one character at a time. Read a character while character is converting this into C gives. Read a character while character is not end of file indicator. Output the character just read. Read a character then again. Okay, include stdio copy input to output first version main int c, that is we are using c to store an integer, and okay, and getChar returns a character into c, and while c is not equals to end of file we put that character onto the screen and then we update c with the new character. The operator this means exclamation equals means not equal to. What appears to be a character on the keyboard or screen is of course like everything else is stored internally, just a bit pattern. The type char is specifically meant for storing such data, but any integer type can be used. We used int for a subtle important reason. The problem is distinguishing the end of input from valid data. The solution is that getChar returns a distinctive value when there is no more input, a value that cannot be confused with any real character. This value is called end of file. For EOF, we must declare C to be a type big enough to hold any value that getChar returns. We cannot use char since C might be big enough to hold end of file in addition to any possible character. Therefore, we use int. Because int is bigger and char is only a byte long. It might not be able to store end of file. End of file is itself represented as an integer in standard input-output library, but the specific number value doesn't matter as long as it is not the same as any character value. That also makes sense. By using the symbolic constant, we are assured that nothing in the program depends on the specific numeric value. That nothing in the program depends on the specific numeric value. Yep, the program for copying would be written more concisely by experienced C programmers and C assignments such as getChar is an expression and has a value, which is the value of the left hand side. Left hand side after the assignment. This means that okay, so this returns a value, which is the value of the left-hand side after the assignment. This means that a assignment can appear as a part of a larger expression. If the assignment of a character to C is put inside the test part of a while loop, the copy program can be written this way. Take an integer C and while get C is not equal to end of file, keep doing this. The while gets a character, assigns it to C, and then tests whether the character was the end of file signal. If it was not, the body of the while is executed, printing the character. The while then repeats. When the end of the input is finally reached, the while terminates, and so does main. That makes sense. This version centralizes the input. There is no now only one reference to get char and shrinks the program. The resulting program is more compact and once the idiom is mastered, easier to read. You will see this style often. It's possible to get carried away and create impenetrable code, however, a tendency that we will try to curb. The parentheses around the assignment within the condition are necessary. The parenthesis of this not equal is higher than that of equal, which means that in the absence of parentheses, the relation test not equal to would be done before the assignment, not the assignment. Is equivalent to this. This this. So C will get true or false, like 0 or 1. This has the undesired effect of setting C to 0 or 1, depending on whether or not the call of gets are returned end of file. More on this in chapter 2. Exercise 1.6, verify that the expression get is not equal. Okay, write a program to print the value of UF. EOF.c include stdio.h and int main void, and in here I have int c equal to EOF. There is an error. Nope. Printf %d new line OF clang it and clang EOF.c and output should go to the ./output, and here is the output. End of file is equal to -1. Character counting. In the morning we did word counting in assembly language. Now the next program counts characters. It is similar to copy program. It takes a long number count, initializes it to 0. While the character coming is not equal to end of file, it keeps pre-incrementing the character printf. Long digit NC. A statement is okay. Let's do count chars dot c. Yeah, not include next. Include standard IO, and in here we have int main, and in that would like to have long digit, which is char count, and while get c. What the heck? Oh, ld equals 0. Oh, oh, okay. It should be long. Char count, and while this is not equal to end of file, what do I have to do? It should, it has to be get char, not get c. I will char count, increment it, and at the end printf number of characters are percent %t new line, not percent %d but long digit, up, 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 long digit, and the input to the long digit is this, and clang count characters to the output dot out, and now running the program. I give it a lot of characters, and end of line is percent %d. Oh, sorry, control D, right? Yep. Control D, number of characters is 209. The statement, this is NC presents a new operator plus means, which means increment by 1. You could instead write NC equals NC plus 1, but plus plus NC is more concise and often more efficient. There is a corresponding operator minus minus to decrement by 1. The operators plus plus and minus minus can either be prefixed plus plus NC or postfixed characters. NC plus plus, these two form have different values in expressions, as will be broken down in chapter 2. But plus plus NC and NC plus plus both increment NC. For the moment, we will stick to the prefix form. The character counting program accumulates its count in a long variable instead of an integer. Long integers are at least 32 bits. Long integers are at least 32 bits, although on some machines int and long are the same size. I guess in my machine. On others, int is 16 bits with maximum value of 32,000, and it would take relatively little input to overflow an int counter. The conversion specification percent details printf that the corresponding argument is a long integer. It may be possible to couple with even bigger numbers by using a double precision float. We will also use a for statement instead of a while to illustrate another way to write a loop. We will use a for statement instead of a while statement. Okay. Main. We don't have an integer int main. Okay, we just have main, and we have here double, which is, we have a variable nc which takes double, that is 64 bits. For nc equals 0, get char is not equal to end of file and incrementing char, and on the next line we have a semicolon to specify that we have nothing here. That is for syntactical reasons there. And then printf the number of characters. Okay, printf uses %f for both float and double. Printf dot 0 suppresses the printing of the decimal point and the fractional part, which is 0. The body of this for loop is empty because all the work is done in the test and increment parts, but the grammatical rules of C require that a for statement have body. The isolated semicolon called null statement is there to specify that requirement, but put it on a separate line to make it visible. Before we leave the character counting program, observe that if the input contains no characters, the while or for loop test fails on the first call to get char and the program produces 0, the right answer. This is important. One of the nice things about while and for is that they test at the top of the loop before proceeding with the body. If there is nothing to do, nothing is done, even if that means never going through the loop body. Programs should act intelligently when given zero length input. The while and for statements help ensure that programs do reasonable things with boundary conditions. Okay, my bad. Now on to line counting. In line counting, we can count the number of lines. Yep, that should be easy to count the number of lines by counting the number of new lines. And then, yeah, because every line has a new line character at the end. The next program counts input lines as we mentioned above. The standard library ensures that an input text stream appears as a sequence of lines, each terminated by a new line. Hence, counting lines is just counting new lines. Okay, integer we have a count and the number of lines. Number of lines starts at 0 while the character is not equal to end of line. We see if the character is equal to the new line, and if it is, then we pre-increment our new line character, and after the while loop we print the number of lines. The body of the while now consists of an if, which in turn controls the increment plus plus nl next new line. The if statement tests the parenthesized condition, and if the condition is true, executes the statement or group of statements in braces that follow. We have again intended to show what is controlled by what. That makes sense. The double equal sign is the C or notation for is equal to, like Pascal's single equal, or Fortran's dot EQ, like dot EQ means equal. This symbol is used to distinguish the equality test from the single equal. The equality This symbol is used to distinguish the equality test from the single equal that C uses for assignment. A word of caution. Newcomers to C occasionally write equal when they mean equal equal, as you will see in chapter 2. The result is usually a legal expression, so you will get no warning. Because when you assign, you get assignment is also an expression, and that returns the value that is assigned. A character written between single quotes represents an integer value equal to numerical value of the character in the machine's character set. A character written between single quotes represents an integer value equal to the numerical value of the character in the machine's character set. That is called a character constant. Character constant. Although it is just another way to write a small integer. So for example, single quotes capital A is a character equal to 65, and small a would be equal to 97. Is a character constant in the ASCII character set. Its value is 65. The internal representation of the character A, of course, capital A, is to be preferred over 65. Its meaning is obvious, and it is independent of the particular character set. The escape sequences used in string constants are also legal. in character constants. So backslash n stands for the value of the new line character, which is 10 in ASCII. You should note carefully that backslash n is a single character and in expressions in is just an integer. On the other hand, backslash n is a string constant. You should note carefully that backslash n is a single character and in expressions is just an integer. Ah, okay. If we use that in an expression, it will be used as an integer and its integer value is 10. On the other hand, is an integer on the other hand. Backslash n is a string constant that happens to contain only one character. The topic of strings versus characters is discussed further in chapter 2. Okay, waiting for chapter 2. Write a program to count blank, tab, and new lines. Okay, this we should do, I guess. And count blanks, tabs, and new lines. Blanks, tabs, new lines dot c hash include standard io dot h and then main, and we have integer blank count and tab count and line count, and all of them have are started at 0, or instead of initializing them like that, I can initialize them like this: blank c equal tab c equal line c equal 0. And now I also want a c character which will, while c equals get char is not equal to end of file. What would I want to do? I would like to see what the character is. If c equal, what is a blank? This, then blank c plus plus, and else if c equal tab is backslash t, then tab c plus plus, else if c equals what line is at backslash and then line c plus plus. Okay, okay, and after the while loop, printf blanks %d tabs %d and blanks, tabs, and lines %d, and then we have for blanks we have blank c, tab c, and line c, and at the end this. That makes sense. Not that program. Count blanks. The output should be dot out. Running the program and one line, 1 2 3 4 spaces, line, one more space, tab 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 %d. I have 9 lines, it seems, 5 tabs and 5 spaces. That seems about correct. I used 4 spaces here, 1 space here, and I used multiple tabs here, like one tab, two tab, and the number of lines is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Es funktioniert. Write a program to copy its input to its output, replacing each string of one or more blanks by a single blank. Write a program to copy its input to its output, replacing each string of one or more blanks by a single blank. So I will be using putc, put char function. So now this makes replace blanks dot c, and here we have include stdio, and then int main void and int c, of course. And I don't think that's yeah. We would need an integer I, and integer I will start at 0. It will be there to see if there have been spaces, like let's see, while c equals to get char and is not equal to end of file. What do I do now? I have a character. If c is not equal to blank, just print it. Now put char and provide c, and no. I have to check if it is equal to it, and if it is, then I would like to see, then if I equal to 1, that is there have been spaces before, then do nothing. But if I equal to, let's say, 0, that is this is the first space that we have encountered, then print in space. Yeah, then print in space, put char a space, and if it is equal to 1, and also I equal to 1. What will I do when it is not equal to 1? When it is equal to 1, then nothing. Then else I know that I have a character. I will put I equals to 0 and put char c here. Clang replace / a dot out 1 2 3 4 1 2 3 4 5 6 7 8 9 10. New line, and voila. Voila, es funktioniert. But the thing is that why is it not ending? Oh, because I was not providing it end of file. That makes sense. Write a program to copy its input to its output, replacing each tab T by a blank space and each backslash by backslash. This makes tabs and spaces visible in an unambiguous way. Okay. place blanks, tabs, blanks, tabs, and slash dot c hash include standard io.h and then main, and here I will have int equal to nope, equal to nothing, and then while equal to get char is not equal to end of file. What will I do? While it is not equal to end of file, I would like to do I would like to do what? If c equal to space is, then I would like to print a space, which is put char and put in an actual b. Can I do that? Multi-character constant. Okay, that is shit. Oh yeah, I can take like 2 rounds at that, right? First, this, and then put b. Yep. Now else if c equal to backslash tab and shit. How do I tell it? Backslash tab. Oh, backslash tab. Cheat. That is it. This has to be a backslash. Backslash b. Okay, and here I would like to put char backslash and then put char t. That I think makes sense. And then else if c equals backslash itself, then what would I like to print? I would like to put char backslash, and this statement I would like to put it 2 times so that I have 2 backslashes, or else just put char c. Yep. Replace blanks, tabs, and the output should be dot out. Instead of space, I see bees, and when I do tab, I see tab. Okay, and when I do this, I see oh, not this, but this backslash. It's function yet. It works. And for this, 15 more minutes. That is 440. Word counting. Yep. The fourth in our series of useful programs counts lines, words, characters with loose definition. The fourth in our series of useful programs counts lines, words, and characters with loose definitions. That a word is any sequence of characters that does not contain a blank, tab, or new line. This is a bare bones version of Unix program, WC. WC, okay, what is the WC? WC is word count, I guess. Word count. Can I provide a string here? Hello world, this is me here. Hello world, this is me here. Open no such. Oh, wait, counts. It wants a file as input. Celsius.c has 32, 52, and 450. Okay, it has like, I guess, 32 lines, 454 something, and 450 characters. Now, this is the way bones define in and define out. One inside a word, outside a word. Okay, count lines. Int C new line and new word and new count and state. There are quite a few things here. After that, we have arrays. Okay, I guess we can complete this much here at least today. Okay, focus and lock in. We have C, which will contain the character, number of lines, number of words, number of counts, and a state that is either in or out. Okay, state, before running the program, we are out of it and initializing to zero everything, and we are getting the character on this line. We can increase the character count, we know, and then if C is new line, then we increase the new line character. If C is a space, a new line, or a tab, then we make space out. The state is out. Else, if it is not any of these, and if state is out, okay, if C is not any of these and space is out, that is we just got into a word, then we put state equal to in and new word plus plus. That makes sense, and then we print everything at the end. Every time the program encounters the first characters of a word, it encounters one more word. One more word. Yep. The variable state records whether the program is currently in a word or not. Initially, it is not in a word, which is assigned the value out. We prefer the symbolic constants in and out to the literal variables 1 and 0 because they make the program more readable. In a program as tiny as this, it makes a little difference, but in larger programs, the increase in clarity is well worth the modest extra effort to write it this way from the beginning. You will also find it's easier to make extensive changes in programs where magic numbers appear only as symbolic constants. Okay, and I would like to deep dive into the get char and put char functions. Now, those are good. The line, this, yep, sets all three variables to zero. This is not a special case, but a consequence of the fact that an assignment is an expression with a value and assignment associated from right to left. It's as if we had written this. Makes sense. The operator, this means or. So the line, if C equals to a space or new line or tab, reads as if C is space or new line or a tab. Recall that the escape sequence tab is a visible representation of the tab character. There is a corresponding operator hash hash and for and its precedence is just higher than or. Expressions connected by and or are evaluated left to right, and it is guaranteed that evaluation will stop as soon as the truth or falsehood is known. If C is false, there is no need to test whether it is a new line, or if C is a blank, then there is no need to test whether it is a new line or tab. So these tests are not made It isn't particularly important here, but is significant in more complicated situations, as we will see soon, very soon. The example, as shown and else, which specifies an alternate action if the condition of the if statement is false. The general form is this: if expression a statement, else is a statement. Statement 1, statement 2. One and only one of the two statements associated with an if else is performed. If the expression is true, statement 1 is executed. If not, then statement 2 is executed. Each statement can be a single statement or several in braces. In the word count program, the one after the else is an if that controls how statements in braces that controls two statements in braces. Now, exercise 11. How would you test the word count program? What kinds of inputs are most likely to uncover bugs, if there are any? Word count program. Well, the way that it counts characters is correct. Nothing seems like there can be no bug in it, right? It just increases the character counter by one every time it sees a character. And for new line is also works because at the end of every line there is a new line character that specifies that this is a new line. So that works. But the only place when this new line, the way that they are calculating new line, can be tricked is if the last line does not have a new line character at the end. And in that case, it would return one less than what the actual value should be. And what can we do with it? We can see if what can we do? We In that case, what would happen? Well, we can figure out something. And what about the way that it is counting words? Well, if we have an apostrophe or a comma which has two spaces at its side, it will count that as a single word, which is ridiculous. Or if we have a full stop with two spaces at its side, it will also count that as a word, which is also ridiculous equally. Write a program that prints its output one word per line. Okay, and one word per line dot c. Include stdio.h, then int main, and here we have c equals nothing, and while c equals get char and is not equal to end of file, we would like to see if c equals to a new if c equals to space or or c equals to a new line character. If any of these things happen, then we put character c no then we put new line there, else we just put c in there. George Hertz. Do this should work. The lang one word per line and dot slash out. Nope, dot slash out is not the function I want to see. Make the output file go to dot out and now dot slash out. Hello world, this is me here trying to make a function that prints one word per line, and let's see if it works. It does work. Okay, so we did today's part, and shit, it is not 2 hours long, so we will have to make it 2 hours long by doing. Maybe we can get into arrays, but it is long, and we will not be able to complete it. What we can do is do a little thing. Let me show you something. Jetpunk. And this is a website which you can use to do quizzes. And let me do some quiz. Uh, I use this to do quizzes of capitals right now. That is what I'm learning. Capitals of the world. Yeah, 5 minutes. That is good. Albania. What is the capital of Albania? Tirana. Tirana. Andorra. Andorra. La Vida. Andorra. Valid. Ah, shit. I forgot the capital of Andorra. But it is Andorra something. Austria. Vienna. Belarus. Minsk. Belgium. Brussels. Bosnia. Sarajevo. Bulgaria. Sofia. Croatia. Zagreb. Czech. Prague. Denmark. Copenhagen. Estonia. Tallinn. Tallinn. Finland. Helsinki. France. Paris. Germany. Berlin. Greece. Athens. Hungary. What the heck? Budapest, of course. Iceland. Reykjavik. Reykjavik, Ireland. Dublin. Italy. Rome. Kosovo. Pristine. 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 Prestige. Princeton. Princetis. Shit. I will get back to it. Latvia. Riga. Liechtenstein. Vaduz. Lithuania. Vilnius. Luxembourg. Is it Luxembourg? Luxembourg City. Yeah, Luxembourg City. Malta. Malta is the small place below. Yeah, Valletta. Moldova. Chisinau. Monaco. Monaco. Montenegro. Podgorico. Podgorico. Podgorica. Netherlands. Amsterdam. North Macedonia. Skopje. Norway. Oslo. Magnus Carlsen. Poland. Warsaw. Portugal. Lisbon. Romania. Bucharest. Bucharest. Russia. Moscow. San Marino. Serbia. Belgrade. Slovakia on the top right above Hungary. Bratislava. Slovenia. Ljubljana something. Spain. Madrid. Sweden. I do not want to get this wrong. Fucking hell. Sweden. Stockholm. Switzerland. Bern. Ukraine, Kiev, UK, London, Vatican City. Okay, what are remaining? Kosovo is something Pristina, Prince, Princeton's, Pristina. Okay, Andorra Andorra la Vela. Okay, that was good. My best time is this time I used 4 minute 33 seconds and best is 4:15. Okay, not very good, but okay, we have completed the 2 minutes mark, 2 hours mark, and that was good. So for tomorrow, we will complete the arrays and functions and arguments, call by value, character arrays, and then external variables and scope, and then hopefully this that is going to be the target. Okay, so we will complete the whole chapter tomorrow. Will we complete the whole chapter tomorrow? Yes, we will. We stuck through today and we will stick through tomorrow. Bye.